Hey everybody, I'm Tom Zaidel,
And I'm Michelle Maharbis.
and today we're going to talk about the comparator. It's an open loop amplifier, and it's our first amplifier.
Yeah, it's a really neat introduction to amplifiers in general, and maybe more importantly, it's going to help us with our little issue on reading that Wheatstone bridge in the robot. Okay.
All right, so before we do that, we have to talk, as we promised, about ground as a reference point. We've sort of been talking about this throughout the course, but now's the time to formally define ground. Now, there are many different meanings for ground. The way we're talking about it in this course is as a reference point for potentials. Now, as you remember, let me go ahead and draw a little circuit here. If we have a bunch of resistors like this,
So this is just any old circuit?
any old circuit, and these are all resistors. Let me just finish it up here. So this is a fairly complicated circuit. There's a lot of resistors in there. And when we were talking about voltages in a resistor circuit like this, or the Wheatstone bridge, we defined each resistance explicitly as the difference between two points.
Yep, I remember that.
Circuit,
Yeah.
right? So let's say this was R1, we called this VR1. Let's say if we called this R2, this we would call VR2.
Right.
Now, in order to simplify this notation a little bit, we come up with a concept of ground. And ground is when we pick one node as a reference to reference all the other potentials in the circuit too.
Okay, I have a suspicion we did that in the Wheatstone bridge, but maybe we're going to take it a little farther. So what's the point? I'm not quite sure.
Well, so for example, you could write any potential in the circuit then as the difference between the potential of this node and this reference node. So for example, for this resistor R3, I could look at the difference from reference to this node up here and call it V of R3. Or since it's implicitly understood that VR3 is referenced to ground, I can just call this node VR3. And similarly, if this node has a potential across it, R4, we can just say, okay, I know that that this node is VR4 higher than ground, and I can call this VR4.
Okay, so let me try this. And I think the labels don't really matter as much once we're in this world. So for example, let me try. So I can pick this node, and I can give it any label. Let's call it VA. So you're saying now I could say something like VA equals 2 volts. And the reason that means something is that what I've implicitly said is that what I mean is 2 volts with respect to here. So it's almost like I'm saying this point is 2 meters above ground. We've defined what like sea level is or what ground is. And so of course the differentials still apply, but it's also true that we can kind of talk about points always in reference to how high a potential they are above ground. Is that the point?
Exactly.
Okay.
And if I draw on the right here just the ground, if you have a building, we do this with buildings all the time where we're talking about the 10th floor, that's really 10 floors above ground.
Okay.
Ground is our reference, and we can also say, basement 4. This is 4 floors below ground.
I see. And so, but it's always reference to ground. And of course, the differentials still apply. So if I have a second building and that's, 5 floors, then talking about the difference between the two, kind of what we do for these resistors being 5 floors, and that still works. Okay, I get it. So let me throw in a couple of things about ground. Ground is kind of can get a little bit complex as you move into analog circuits because there's a number of definitions that can apply when a professional engineer is talking about ground. The one we're using is a very straightforward one, and it's simply, we call ground where we're picking as a reference point, the reference point we're picking for the potentials all around our circuit. There's an additional thing you should consider with respect to ground that comes up when you're building real circuits, and that's that often one of the nodes, usually reference node, but it gets a little more complex, can be connected to a very large source of electrons, like the ground. That's actually where both the symbol and the word ground came from. You could have a big piece of metal that's pushed into the ground, or the more common one you see these days is the third, in a 3-pin outlet on the wall, you would see that third ground pin. But I want you to, in your minds, distinguish these things for now. We've provided a whole bunch of interesting links for those of you that like to explore further. You can kind of read about ground. But for now, all I want you to think about in terms of linear circuits is that ground is simply the reference point for us to be able to talk about the voltages at various points and know that implicitly they're differential with respect to ground, but we can now just free ourselves to kind of say the voltage at this point is 4 volts, the voltage at that point is 2 volts. Okay.